Okay, good morning everyone. We're going to work on notes for 14.5, which is over the difference of squares and perfect square trinomials. So last time we learned how to factor using that factor by grouping and that trial and error method. This is a special case of factoring trinomials. And so this difference of squares and perfect square trinomial is only going to work on these special cases, okay? And the special case here is that a squared minus b squared, which could be written as the factor a plus b, a minus b. So this a and b could either be a variable or a number. So this could be a variable or a number. For example, it could say something like x squared minus 5 squared. Okay. So then we would write this as x plus 5, x minus 5. Notice when you square the 5, you get 25, and 25 is an example of a perfect square. More of these examples are below, so more examples of perfect squares. So for example, 9 is 3 squared, 81, 9 squared, 144, 12 squared, so on and so forth for the numbers. When we see that in case of variables, so like right here, these are all the variables that we could write as perfect squares. So just remember, when we have a exponent raised to another exponent, in terms of property of exponents, we multiply, okay? So that's how they multiplied these to get 4, this one to get 6, this one to get 10, okay? So when we think of perfect squares, we can also think of the opposite of like the square root. So for the numbers, the square root of 144 is 12. Okay, it's a perfect square root. If we were looking at the square root of x to the 8th, that would be x to the 4th. Okay, so this is a good chart to have with you until we start getting it down and you're able to do this without any of the help from the notes. Okay, so those are the most common ones we're going to see. Okay, so let's go ahead and look at some examples. So for example 1, we have y squared minus 25. So our first thing here is to check if each of these are a perfect square. So can we take the square root of both? Yep, so we can take the square root of y squared, and that's going to give us what? Y. And we could take the square root of 25, and that's going to give us 5. So from our definition above, we know that it's going to look something like a plus b, a minus b. Meaning when we write our two factors, one factor is going to have a plus, one is going to have a minus. So that means our answer here is y minus 5, y plus 5. And we could always check our work to see if this is correct. Okay? How could we check our work when we have our two factors? FOIL. So the FOIL method is when we have two binomials, right? So we would FOIL the y, and then FOIL that negative 5. And when we do that, we have y squared plus 5y minus 5y minus 25. Notice how the insides cancel, and I'm just left with y squared minus 25, which was our original problem. So that's a way to check your work. So now let's look at number 2. Okay, notice in number 2, that we still have those two terms, but each term has two components to it. So we're going to take this, see if we can take the square root of each one. So can we take the square root of 49?
Yes.
Yep. Square root of s squared? S. Can we take the square root of 4? 2. And what about the square root of t to the fourth? T squared. Okay. So following our formula of a plus b, a minus b, we're going to take the answers that we got once we took the square root, and we have 7s plus 2t squared and 7s minus 2t squared, and that's our answer. Okay, again, these are special cases called perfect squares. So this is how to factor a perfect square. If we get to a problem where we cannot take the square root, that just tells us that this problem is not a perfect square. It's not a special example. That does not mean it has no solution. Okay? That just means that we can't use this method to factor it. And we would have to go and use the method that we learned last class, and that was factor by grouping. Okay. So looking at number 3, right away we see what?
18 is not a perfect square.
Good. 18 is not a perfect square. Anything else that we see that's not a perfect square? Z and what else? 2. So since none of this looks like it has any perfect squares in it, let's first see if we could take out a GCF. Can we take out a GCF here? 2z, right? So GCF 2z, because they both have that variable z. So if I take out a 2z, what am I left with in my first term? Good, 9w squared. And what am I left in my second term? Minus 1. Okay, now let's look at only this inside part. Do we now have perfect squares? Yeah, so we could take the square root of 9 and get what? 3. Square root of w squared? W. And the square root of 1? 1. So we're still using that a plus b, a minus b. So that tells us inside the parentheses we have 3w plus 1 and 3w minus 1. What do we do with that 2z?
Bring it down.
Bring it down. Okay. Yes.
In terms of formatting, would it be like those two, 3w plus 1, 3w minus 1, would that be also in parentheses, or?
Oh, like an additional parentheses around them? That's a good point. We don't have to add the additional parentheses around this because of the properties of multiplication. So since these are all being multiplied together, it doesn't matter the order that they're being multiplied together. So we don't need these like extra brackets or parentheses here. Okay, so before we start, is this a problem that has perfect squares in it?
Yes.
Yeah, so what's that square root of 25? 5. Square root of q squared? Square root of 49? And square root of w squared. So that means my first factor is going to look like what?
5q plus 7w.
Good, 5q plus 7w. And then what's going to be different about that other factor?
Minus 7w.
Good, minus. 1's plus, 1's minus. And again, the reason for that is when we check our work and we FOIL this, those inside terms have to cancel out. Because if you notice, In all the problems we've done so far, there is not a middle term in our original problem. So we know our factors have to have 1 plus, 1 minus in order to cancel out those middle terms. Any questions so far? Next concept here is sum of squares. So it says, suppose A and B have no common factors, okay, meaning we could not take out a GCF. Then the sum of squares, A squared plus B squared, is not factorable over the real numbers. So in that case, if we see A squared plus B squared, then we say our answer is prime, okay? So remember up in the first concept, when we were looking at that definition, it was the difference of squares. So we had A squared minus B squared. That is the only time we're able to use the perfect square method, is because we were taking the difference of the two. Because if we look back at the examples that we just did, notice that each one of these had a subtraction sign in between the two terms. In this next concept, it's saying if we have an addition sign in between the two terms, even if they are perfect squares, we cannot factor them, so we would have to label them as prime. So that means for these examples 5 and 6, because of that plus sign here, the answer is prime. Because of this plus sign, the answer is prime. And we could look further into that by trying to factor this. Let's say you go and you try to factor this, and you know that the square root of p squared is p, and the square root of 9 is 3. Well, in order to get a positive 9, that means both of my factors have to have that plus sign in the middle. So p plus 3, p plus 3. But if I was to FOIL this out, this would be p squared plus 3p plus 3p plus 9, which gives me p squared plus 6p plus 9. Notice how it has that middle term, which number 5 does not. Okay, so that's why these are prime. So again, this is wrong. This is just showing you why. Okay, now we're looking at these examples, and everything's kind of mixed up in here. We have some that have our special case that we just learned, and then we have some that uses that factor by grouping that we learned last class. So let's look at number 7. So remember, for the special case, we're looking for two things. We're looking if we can take the square root of each term and what? The sign. It has to be a minus sign. Okay. Since we have both of those, we can start taking the square root. So what's the square root of w to the 4th? W squared, and the square root of 81? 9. So that means our answer here is w squared plus 9 and w squared minus 9. Look at number 8. Number 8, do we have a minus separating our two terms?
Yep.
And are both our terms, can we take the square root? Mm-hmm. So that means this is the special case. So I'm going to take the square root of y to the 4th, which gives me y squared, and the square root of 1? 1. So that means my answer is going to be y squared plus 1 and y squared minus 1. Okay. Okay, number 9, we have 4 terms here. Remember, if we see 4 terms, we're going to do factor by grouping. So I'm going to group the first 2 terms and the second 2 terms. Once I group each of them, I'm going to take the GCF out of both. So what could I take out of the first parentheses? Y squared. If I take out a y squared, I'm left with y minus 5. What could I take out of the second parenthesis? -4. And I need to take out that -4 because I want the inside of that parenthesis to match that y minus 5. Since my parentheses match, I have an answer of y squared minus 4, my outside terms, and y minus 5, my parentheses. Is this completely factored?
No.
No, what is not completely factored here? This first parenthesis, right? Because this first parenthesis looks like the special case of perfect squares. Okay? So that means we continue factoring by taking the square root of each of these terms, and we get the square root of y squared is y, and the square root of 4 is 2. So that means just for that first parenthesis, I now have that separated even further as y plus 2, y minus 2, but I have to bring down that y minus 5 because that was part of my original factor. So now this is factored completely. So if on an exam you stopped here and didn't continue your problem, you would be marked off points, okay? Because that only got part of the problem, and it said factor completely. If it ever says factor completely, that's your hint that there's going to probably be more than one step that you have to do when factoring. Any questions so far? Go ahead and take a moment and try number 10. Number 10 has 4 terms, so you're doing what first? Factor by grouping. So you're working on number 10. Give you guys a moment to do that, and then I'll go through it. Okay, as you're working through it, I'm going to start taking the GCF out of each one. And then you compare with your work. Once I had the GCF taken out from each, I have p squared minus 9 and p plus 7. Is this the answer, or do we have one more thing to do?
One more thing to do.
One more. We have to still factor that first parenthesis because we noticed that it is that perfect square example. So you should have got p plus 3, p minus 3, p plus 7 as your answer. Any questions? Okay, so now we're looking at the concept factoring perfect squared trinomials. Okay. So in order to place a trinomial into that factored form of a perfect square, we have two examples here. We have if our problem is a squared plus 2ab plus b squared. So that tells us that this middle part right here is going to be positive and it's going to be double the a and b value. Then our factors would look like this. And we saw that before in the examples which we labeled prime in the beginning, okay? Because we were just talking about the perfect square special cases. Now it's showing you how we would factor those. And then this case where now the middle term, that b term, is negative, okay? Right here. Okay, in order to check if we have a perfect square trinomial, we first determine whether the first and third terms are both perfect squares with positive exponents. So we're going to check the first term and the last term. They both have to be positive, and they both have to be able to take the square root from them. If this is the case, we identify a and b and determine if the middle term equals 2ab or negative 2ab. So again, we'll see that in the examples here. Okay. So first, looking at our first two terms. So we have in number 11, we have x squared and 49. So our first thing is to check, are they both positive?
Yes.
Yep, both positive. Are they both perfect squares? Yes. So then we check here, okay, the perfect square, if we take the square root of x squared, we get x. And if we take the square root of 49, we get 7. So that's our first step. Now we take that square root of 49 where we got 7, and we have to see if that middle term of 14 is double 7. Is 14 double 7? Yep, because we could do 7 times 2, which is 14, and that's what we're checking for. Since that middle term is also positive, that means we are looking at the formula right here at the top. So that means it matches this formula. So that means our answer is going to be that a plus b squared. Okay? So that tells us x plus 7 squared. So again, these are more special cases. We just have to check if all those conditions are true. If it's true, then we're able to factor right away, and we write our factor as a plus b squared, or a minus b squared. What's another way to write this? What does that squared tell us? Good. We could write x plus 7 and x plus 7. That's the same thing. So if you write either answer, that's exactly the same, because that x plus 7 squared is telling us that we have x plus 7 2 times. Okay, now let's check our criteria for number 12. We're first looking at our a and c values, so our first and last terms, and we are checking to see if they are what?
Positive.
Positive, so are they positive?
Yes.
Yep. Are they perfect squares? Yeah, they are. So we can take the square root of the first term and the last term. So the square root of 25 is 5, the square root of y squared. Square root of 4, 2. Okay. So that was our first criteria met. Okay. In the first one, in number 11, when we were checking to see if that middle term was double the 7, that was because there was not a number in front of our x squared. Now that we have a number in front of our x squared, we have to take those two numbers, so 5 times 2, and we get 10, and we have to check again, is our middle term double 10? And it doesn't matter if it's positive or negative. Is it double 10? Yes. This is double 10, because 10 times 2 gives us 20. That negative here tells us when we're writing our answer, instead of a plus b squared, it's going to be a minus b squared. So in this case, our answer is 5y minus 2 squared. And again, these are problems that in the future, as you're doing them more and more, that you won't necessarily have to write all these steps down because you're going to do that mental checklist on your own. Okay. Okay, now on 13. On 13, our first thing is to see if our first and last term is positive. Is that true?
Yes.
Yep, because 18 and 32 are both positive. Then we're checking to see if they are perfect square roots. Yes or no? Good, no, there's not, because we can't take the square root of 18 and we can't take the square root of 32. So right away that tells us that we are going to have a what? A GCF. What would that GCF be? Any guesses? C. So the C is correct. The 6 won't go into the 32. Any other guesses? So 8 won't go into the 18. Think smaller. 2. 2C. Okay. So if we factor out that 2C, we're left with 9c squared minus 24 CD, because we're only taking out one of those c's, plus 16d squared. And that was us just factoring out the GCF of 2c. So now we're only looking at this middle part. Now we're going to go back and go through that criteria again. Is our first and last term positive? Yep. Is our first and last term perfect squares? Yes. So we're going to take the square root of 9 and we get 3, square root of c squared, and we get c, square root of 16, and square root of d squared, d. Okay. What is our next step? Good, we multiply 3 and 4, and we get 12. What's our next step? We have to multiply that 12 by 2, and we get 24. Does that match our middle term? Yes, right here. So since it matches our middle term, and our middle term has that negative attached to it, our answer is going to have a negative or a positive in it? A negative. So I have 3c minus 4d squared, and then I have to bring down that 2c. Okay, so right away before we determine if the problem is prime or not, so not factorable, we have to always check if we can take out a GCF. If we can take out a GCF and then if our factor is still not factorable, then at that point we would write prime. Okay, does 14 meet both of the first criterias? No, so it meets the positive one, because 5 and 45 are both positive, but they're not perfect squares. So that tells us we have a what? GCF, and what would be the GCF? 5. So if I take out a 5, I'm left with w squared plus 10w plus 9. Now looking at just the middle part, once we factored out the 5, does that equation meet the first two criteria?
Yes.
Yeah. So we could start by taking the square root of w squared, and that gives us w, and the square root of 9, which gives us 3. Okay. What's our next step? Multiply. So what's the number in front of w if we don't see a number? 1. So 1 times 3 gives us 3. And then now what are we doing? Doubling it. So 3 times 2 gives us 6. Does that match our middle term? No, that does not match our middle term. So all that tells us is that this is not a perfect trinomial. So not a perfect trinomial. That does not mean we can't solve. Okay, so if we had w squared plus 10w plus 9 as just a problem by itself, we could just solve it by doing that factor by grouping that we did last time. Okay, so that means we're expanding that middle term by finding a term that multiplies to that a times c, which is 9, but adds to b, which is 10. So just like we did last class. So we need factors of 9 that multiply to 9, but add to 10. What would be those factors? 1 times 9, because if we add that, we get 10. So that means expanding our b value, we get w squared plus w plus 9w plus 9, because I used those factors of 1 and 9. Then I do my factor by grouping and take out a GCF from each of them. So in the first one, I can take out a w, and I'm left with w plus 1. And then the next one, I can take out a 9, and I'm left with w plus 1. Since both my parentheses match, I know I did everything correct. So that means I have the answer w plus 9, w plus 1, and I bring down that GCF of 5 in the front. Okay, so for this problem, I tried to see if it was a perfect trinomial, to see if I could do that shortcut way to get my answer. I found out that it's not a perfect trinomial, So my next step was to see if I could factor it by grouping, which I could. Okay. Let's see. That's the end of that one.